Hello, everyone. Welcome. Can you hear me? Can you hear me, Danilo?
Oh, yes, I can hear you. I
Oh,
guess
great.
you get little bit laggy, but everything's
Yeah.
we can
É,
hear you.
but let's switch to Portuguese again. Sorry. Olá, pessoal do SouJava. Sejam bem-vindos a mais uma live aqui do SouJava na Geecon. Hoje nós vamos ter um convidado muito especial, por isso que a gente está falando em inglês, então desculpa, mudou o switch para o português que demorou um pouquinho. Mas eu queria agradecer a presença do Danilo aqui, que está ajudando a gente mais uma vez aqui nesse evento. Danilo, por favor, algumas palavras aí para começar a
Oh,
nossa live.
fala pessoal, fala Max, tudo bem? Pô, é um prazer estar aqui junto a essa incrível comunidade aqui, eu sou o Java, sempre disposto aí a estar colaborando aí com conteúdos, com as pessoas, tudo. E hoje eu vou estar ajudando aí a hostear a live que a gente vai ter aí de um grande amigo nosso que a gente fez lá na Europa ano passado, na EclipseCon, certo?
Sim, sim, ele é um cara bem bacana, ele traz um conteúdo bem relevante, ele já falou sobre Virtual Threads, ele está falando sobre várias outras abordagens interessantes, mas eu vou mudar para o inglês, porque provavelmente nós temos uma audiência em inglês também, então vou mudar para o inglês. Então, welcome everyone that's here with us, attending this live session. So, welcome. Have a good night. Have a good day. Have a good morning, wherever you are. We got a special guest on here in this SouJava. We meet him in EclipseCon last year when we attended there. Am I right, Danilo? Danilo also
Yes, exactly.
coming to me, and he's a special one that used to talk about many features of Java, for example, virtual threads, pattern matching, algebraic data, as we are talking today. And Danilo, you want to speak something before to bring in our guest?
Yeah, sure. Just remember, just talking about our guest, that he also did a lot of presentations all around the world, so mainly focusing in Europe. So Geecon, JCon, and JavaLand last month. So he's an amazing speaker, and he will be here in our stage. It's a pleasure to have someone like him, in this celebrity here in our stage with this such cool things about Java. That's amazing.
Yeah, amazing. And he will be in a JCon in a couple days. Am I right? I will bring him. Let's stop to
Yeah.
speak and then bring him right here to stage. So, Danilo, call him, please.
So everyone, welcome Bala, our friend from Europe. Hey Bala, how are you doing, man?
Hey Danlo, hey Max. I'm doing good. How are you doing? Really great to be here. Great to be here in the SouJava Java user group. Amazing. I mean, we met at EclipseCon, and we always spoke that I will be at least doing some talk here, and it's really great to be here. I was also humbled by the introduction you guys did. Okay, that was awesome. Thanks a lot.
No, you are a special guy that used to share a lot of amazing content. And last time when we meet in person, we have been speaking about virtual threads and so on EclipseCon.
Yeah.
And also, I did a question there. Like, do you remember about that? That was
Yes,
very
I do.
amazing. And today you are gonna talk about algebraic data and data-oriented programming and pattern match and so on. And if you guys on the chat, if you are watching us, feel free to send question at the chat. Don't care about if you don't speak English. Please type in Portuguese. We can try to translate it and bring it to Bala. And thanks again, Bala, for being here. It's a honor. And also, Danilo will be here together, and he can help us with anything that you need. Okay. So, Danilo, do you have some words before to bring the stage to Bala?
Oh no, I'm okay. So I guess it's showtime,
Yeah,
Bala,
it's the
that's
show
your
time.
time. Go ahead, and if you need any help, I will be here on the backstage. Max will be here with us. So if people that are watching us has any question, send on the chat. We are going to do it to Bala and get your questions answered. So let's go, guys.
Okay, so I will share my screen and put us in the backstage. Okay, Danilo.
Okay.
Okay, take it away, Bala. Have a good
Well,
show.
thanks, guys. Okay, well, thank you, Max and Danilo, for an amazing introduction. And well, welcome everyone to the talk. I'm going to be talking about algebraic data types and pattern matching in Java and how they help us to write elegant and readable Java code. So let's get started. So the way this presentation is going to go is we'll divide it into 4 parts. So we'll start with a problem. We'll analyze the problem. We'll also think about a solution of that problem. We'll design a solution, and then we will implement that solution using algebraic data types and pattern matching. And then in that process, we will create easy to read and easy to understand code. So that is going to be our process for this talk. About me, I am Balkrishna Rawool. I work at ING Bank as an engineering lead. And you can also see my Twitter handle there. So if you have any questions, you know where to find me. Okay, this talk is for 45 minutes, but if you have any questions, just shoot them in between, just put them in the chat, and Danilo can help redirect your questions to me. Don't wait until the end, just shoot your questions and I'm there to answer. Okay, let's start with the problem. So the problem that we are going to solve is actually a puzzle, and the puzzle looks like this. So what we see here is that we have a mathematical expression, but the numbers are replaced by letters. So you see SEND plus MORE, and that equals to MONEY. So 2 4-digit numbers which are added to create a 5-digit number. And the goal is to identify what are the numbers behind these letters. So each letter here has a number, and the idea is to find out what are the numbers behind these letters. Now, I chose this particular problem because it's actually pretty easy to understand, but it is hard to solve. And we will find out why it is easy to understand and why it is hard to solve. So let's look at the rules or the requirements of the problem. So this is the problem that we have. And these kinds of problems are also known as cryptarithmetic puzzles. Here, each letter corresponds to a single digit non-negative number. And all letters have unique numbers. That means you see E appearing here multiple times, and all of these places you have same number behind them, but that number cannot be somewhere else because each letter has a unique number. Letters placed together form a multi-digit number. What that means is SEND here forms a 4-digit number. MORE forms another 4-digit number, and then MONEY forms a 5-digit number, and this addition has to be true. Also, one of the things that we have for this specific puzzle is that the letter M cannot be 0. Now, this actually helps us to solve this problem. Let's see why that is the case. So let's focus on these 2 letters, M and O, right now. Now, these are created by adding these 2 letters, which are again 2 single-digit numbers. Now, when you add 2 single-digit numbers and you get a 2-digit number, that number can be at the max, let's say 9 plus 8, 17. With, let's say, if you add 1 carry, it can be 18, but it cannot be more than that, right? So M here cannot be 2 or 3 or 4. It has to be either 0 or 1. But the rules say that the letter M cannot be 0. That means M has to be 1. So if M has to be 1, and that way we have actually solved it for M. If we continue with this process, we will solve it. We will solve the entire puzzle. We will find out the solution. Now, well, we solved M easily, but if continuing that and solving the entire thing is actually quite difficult. And we will see that why it is difficult. Let's look at the rest of the rules. So then the equality constraint holds true. So send plus more has to be money. Now analyze the problem a little bit. What do we have? We have 8 letters here, SENDMORY, and they are basically unique numbers. And there are a bunch of constraints that are applied to these numbers. And the constraints are, well, each letter has 10 possibilities, 0 to M, except M, because M cannot be 0. It has to be either 1 to 9. So basically, each letter has 10 possibilities. Each letter has a unique value. Again, M cannot be 0. That's one of the constraints. And then as we saw earlier, that means M has to be 1. And then another constraint, which is send plus more, has to be money. Now, these are the constraints that we have. These are the variables that we have. And if we start with all possible solutions, so for example, what are the possible solutions that these letters can have? If we start with only one constraint, we start with 90 million possibilities of solutions. And then we apply each constraint one by one, and then we narrow it down to 181,000 possibilities. Now, this number is pretty high number if you want to do it manually, but it's not that high if you want to do it with a computer. Like if you write your algorithm and then you run it 181,000 times and it spits out a solution. So we can still do that, but doing it manually is pretty hard. So that's why it is hard to solve it manually. And these are the constraints that we have. And when we apply the final constraint, we will have a solution. Well, we don't have it now, but we will have it soon. So this will give us a solution or multiple solutions. So this is basically, if we analyze the problem, this is what we see. Then, if we have these kind of problems where you have a bunch of variables and a bunch of constraints that are applied to those variables, there is an easy way to find the solutions by using constraints programming. And in constraint programming, you have a bunch of variables and a bunch of constraints that are applied to those variables. So it has variables and constraints. And in constraint programming, there is a specific section of problems which are called constraint satisfaction problems. Now, these are the problems where you have a solution when all the constraints are satisfied for these variables. That's exactly what we have, right? We have send plus more equals money and a bunch of constraints. And all the constraints are satisfied, we have a solution. So our problem is actually a constraint satisfaction problem. And that's why I want to discuss constraint programming, because this would help us solve it. So there are a bunch of Java libraries like ChocoSolver, JSolver, OptaPlanner, and MiniCP, which would help us implement constraint programming. But we're not going to use these libraries because this would be too easy to solve it. What we're going to do is we are going to use the understanding of constraint programming to write our own solution. And that way we have it solved using Java and using the concepts that we will learn. So that is what we are going to do. And now let's think about a solution, right? So this is the puzzle that we have. And as I mentioned earlier, you have like 181,000 possibilities. If we apply them one by one, we will finally find a solution. So we can easily brute force this. So that is exactly what we are going to do. What we're going to do is we're going to generate all possible combinations of values for all the variables. We're going to call that component generator. So generator will generate all possible combinations of values for all these variables. Then we're going to create another component called expression evaluator, which will evaluate all these expressions. So this expression plus this, and then it's going to check if these values are matching or not, right? So that is part of expression evaluator to evaluate different expressions. And if all the constraints hold true for a combination of values, so basically you check all these possible combinations that are generated by the generator, you pass them through the expression evaluator, and when all the constraints are satisfied, then you have a solution. And that will be the part of a component called as puzzle solver. So our solution will look something like this. So you have a puzzle solver and you have a generator which generates all possible combinations. You have expression evaluator which evaluates all these expressions. And then you have puzzle solver which basically uses both of these and checks for all constraints. When they are all satisfied, we have a solution. So basically we started with the problem and now we are going to brute force by using this design to solve the problem. So what we have done so far, we started with the puzzle and now we have a high level solution design. Now let's zoom into this part called expression evaluator, because that is where the crux of this problem is. Expression evaluator. What we see, let's take an example of an expression called send. What we see is that there are 4 letters, S-E-N-D. And if we assume that the values of these letters are small letter S-E-N-D, then the value of this expression send becomes S times 1000 plus E times 100 plus N times 10 plus D, right? Now, if we take, or if you want to create a binary tree that represents this expression, then it would look something like this, because the in-order traversal of this binary tree would produce this value. Now, how do we see that? Let's do the in-order traversal for this tree, starting with bottom left, which is S. So this is like S times 1000 plus E times 100 plus N times 10 plus T. So that is exactly what this expression denotes, right? So this is how you evaluate this expression. Now, there's actually something really interesting about this tree, and that is that if you take any node and if you take a subtree with that node as a root, then the in-order traversal of that subtree also produces a valid expression. For example, let's start with this plus. Then the subtree would be this, and the expression would be S times 1000 plus E times 100, which is a valid expression. Then if you take this multiplication sign, then you get this subtree, which is N times 10, which is also a valid expression. Then you have this, let's say take this node, which is D. Again, the subtree is D, and D itself is a valid expression. If you take this node, you get 10, and 10 is also a valid expression. Now, if you think about all the possible valid expressions, and if you want to create a grammar for it, the grammar would look something like this. Now, here what we have, an expression is either a constant or a variable or addition of two expressions or multiplication of two expressions. Now, this grammar would represent all the valid expressions, and it would basically exclude all invalid expressions. So any expression that is valid is representable by this grammar, and any expression that is invalid cannot be represented by this grammar. Okay, so we started with the puzzle. We have a high level design for it. Now we are zooming into the expression evaluator part. Now, if you look at this expression, now these kind of expression or these kind of grammar can be implemented by using algebraic data types. So now let's look at algebraic data types and how they are done in Java. So algebraic data types. What are algebraic data types basically? These are the data types that are created by combining existing data types, mainly by applying algebraic operations. And there are two main kinds of algebraic data types, and they are sum types and product types. Let's look at them one by one, starting with product types. So what are product types? In product type, each value of the new type has value for each of its constituent types. For example, a point has two coordinates, x and y. And in Java, you can implement this by creating a record. So a record point here has integer x and integer y. So if you take any instance of this record, it will have an x value and a y value, right? So it has value for each of its constituent types. So basically this point is a product type of two integer types. Another example, an address has a house number, a street, a city, and a country. And can be implemented in Java by using a record. So a record address here has house number, street name, city, and country. House number, which is int, and the rest of them are string. So basically each address has a house number, street name, city, and country. And that means address is actually a product type, which is a product of one integer type and three string types. So that's about product types. Now let's move on to sum types. In sum types, each value of the new type is one of the values of its constituent types, right? So an example could be shape can either be a triangle, quadrilateral, or a circle. And in Java, you would implement this by using sealed interface. So here you have a sealed interface shape, which can either be a triangle, quadrilateral, or circle, right? So a shape can only be one of these three things. It cannot be anything other than these, and it can also not be like two of these things at the same time, right? So if there is a shape, it is either a triangle or a quadrilateral or a circle. So that's about sum types, and this is in general about algebraic data types. Now let's move on and look at pattern matching, because that is another feature that will help us implement our solution for the problem. So pattern matching. So what is pattern matching? Pattern matching is checking for presence of a pattern in a given sequence of tokens. And in Java, we have a bunch of pattern matching features, and there will be more. But in Java 22, these are the, let's say, most important features that we have. And I will be using those in order to implement the solution. And these features are pattern matching for instance of, record patterns, pattern matching for switch, unnamed patterns, and variables. Now, before we move on, if there are any questions, feel free to ask them. Danilo, maybe if you have any questions, you can also interrupt me.
Oh, so far we don't have any questions about it, so go
Okay.
ahead.
Perfect. Sure. So moving on, what I'm going to do now is I'm going to show examples of each of these features, and then we will basically go through them quickly. But in the end, we will use these again to implement our solution. So starting with the first one, which is pattern matching for instance of. And then this is an example of pattern matching of instance of. What we have here is actually an instance of expression which checks if this object is an instance of point, right? It's an instance of type point. And if it is, it creates a variable called p, which is of type point, and then it uses this. We can use that in the subsequent code. So this not only checks for object to be of this type, but also creates a new variable which is of this type. Then record patterns. So in record patterns, let's say if your point type is a record, you can deconstruct that into its constituent types. So point here is actually a record of integer x and integer y. And in this instead of expression, we not only check for this object to be of type point, but we also deconstruct that into its constituent types, so into x and y, so that we can use x and y in the subsequent code. Then we have another example. So if your records are nested, then you can use the instance of expression to deconstruct these nested records. So for example, shape here is an instance of circle. So we are checking if the shape is of type circle. And circle has a point as a constituent type, which is a record. So we can even deconstruct that. So we can go even deeper. So we deconstruct circle into a point and radius, but we also deconstruct point into x and y. And again, we can use this x, y, and radius in the subsequent part. So that's about record patterns. Next, we have pattern matching for switch. So we saw earlier that shape is an instance of, or shape is basically a sealed interface, which could be triangle, quadrilateral, or circle. Now, if that is the sealed hierarchy, you can use that in a switch expression. So here we are switching over shape, which can be a triangle, quadrilateral, or a circle. And then what we do is basically we don't need a default branch here because this is a sealed interface of these three types. And then depending on which what this shape is an instance of, we can evaluate this right hand side. So in this case, we are basically calculating the number of sides for a shape. So for triangle, it is 3. For quadrilateral, it is 4. And for circle, it is 0. Moving on, we have unnamed patterns and variables. So here we have the same example. And here we are replacing all these variables, which we are not using with underscore. So if you're not using a variable, you can express that intention very clearly by replacing the variable name with underscore. So in this case, we are not interested in the variable names. In fact, we can also use local variable type inference because we are also not interested in the types of these. And so we put var here. The compiler can then figure out based on the records what are these types. But the intention is clear that we are not using these variables. So that's about unnamed patterns and variables. And we will use all of these features in our implementation later on. Okay, so what did we do so far? We started with a puzzle, then we created a high level design for a solution, and then we learned about algebraic data types and pattern matching. And now we're going to put all of these things together and we are going to solve it. So let's get back to the problem that we had and use the understanding of algebraic data types and pattern matching to solve it. So how will our solution look like? What are the solution steps? So this is the puzzle that we started with. This is the high level solution design that we came up with. How are we going to solve it? Well, these are the rules that we have. So first rule is that each letter corresponds to a single digit non-negative number. How do we implement this? For this, we create a type variable to represent each letter. Then we create a type called range constraint to represent possible values of a variable. So a range of the values that a variable can have. Then we create expression type, which will basically implement this expression evaluator part with an evaluation function. Then we will create a type called generator, which is this component, which will generate all possible combinations of variable values. Then we will create more constraint types because there are still some constraints which are not yet satisfied. For example, all values must be unique. That's one of the rules that we have. For that, we create unique values constraint. And then another constraint we have, which is equality constraint must be satisfied. For example, the cent plus more has to be equal to money. For that, we create an equality constraint. So when we have all of this, we create the puzzle solver, which will use generator and expression to find solutions. Now, this looks like a good approach, but let's put it to test. Let's actually implement this, and then we have our solution. So the next thing is implementation, which is basically me switching to IntelliJ, going over these steps that we discussed, and creating a solution for us. So what do we have? First, we're going to create a variable to represent each letter. So let me do that. Let me create a variable type. And let me just quickly check if the font is good enough. So I'm going to create a variable record. Is the font good enough? Danilo or anybody who's in the chat, can you confirm?
Oh yeah, that's good. That's good.
Perfect.
Yeah. Also, just talking here, we have here Java Joiner talking. Hey guys. So welcome Java Joiner. It's a pleasure to have you here.
Perfect. Well, good to have you. Let me carry on. Let me implement the record variable. Now, variable has a name, so I'm going to create a string name. And then the next thing that we saw we'll do is we'll create a range constraint to represent all possible values of variable. So let's do that. That will be another record, which we'll call it range constraint. And this will have two things, an integer from and integer to, because it's a range of that variable. And this range is only for a variable. That's why I put this range constraint inside variable. And it is for a variable. So let's actually use that. So a range constraint is put on a variable. So a variable has range. Okay, next thing. Create expression with evaluation function. And this will be quite interesting. So let's create a new interface called as expression. Why an interface? And for that, let me quickly show you this part, which is basically the grammar that we came up with for expression. So an expression can be either a constant or a variable or addition of two expressions or multiplication of two expressions. And that's why for this kind of grammar, we will use algebraic data types. And if you remember from the example of shape, where a shape can be triangle, quadrilateral, or circle, now we can apply the same thing here. An expression can be a constant, a variable, or addition, or multiplication, right? So we can use sealed interface the way we did it for shape here. And that's why we created an interface. Let's make it sealed. And then let's add this implementation. So we have a record, which is a constant expression, which has a value, and this implements expression. So basically, this means an expression can be a constant. Then an expression can also be a variable, right? So a var expression. And if it's a variable, it has a name. So let's use that. Let's put a string name in here. And then we saw that expression can also be addition of two expressions. So let's do that, addition expression. And when you have addition of two expressions, you basically have an expression which is, say, left expression and an expression which is right expression. And then you have multiplication. So multiplication expression, which again has a left and right side, which implements an expression. Okay, so this is basically how our expression looks like. Then we said expression should also have evaluation function. So let's implement that. For that, we're going to create a static method which returns integer, and it's called evaluate. And this evaluates an expression. So let's pass that expression in here. And in order to evaluate an expression, because it has variables, we need the values of these variables. So I'm going to pass a map of string to integer. Let's call it values. And then with this, we will basically write our evaluation function. So this, what we're going to do is, because it is a sealed interface, we're going to use pattern matching for switch. So let me do return switch over this expression. And because this is a sealed interface, this expression can be only one of these four things. And the compiler knows that. So compiler says, hey, here you are missing some branches. Let's add those branches. So an IDE like IntelliJ helps us to add these branches here. So here you have expression which could be one of these four things, and it can only be one of these four things, right? Cannot be anything else. So there is no default branch. Now what I like to do is I want to put them in the same order as they appear here. So let me do that quickly by moving these. So an expression can be constant expression, a variable expression, an addition expression, or multiplication expression. Again, there is no default branch needed because it can only be one of these four, as denoted by this sealed interface. Now, the constant expression has integer value. So let me get that value out of it. And when you have constant expression, how do you evaluate that? You evaluate it to simply a value. If you have variable expression, then a variable expression has a name. So let me put that here, where name. And if it has a name, how do you get the value? Well, you look it up in the values map. So you do values.get name, and that gives you the value of that expression. Then an addition expression has two things, right? Left and right expression. So let's get those, left and right. And how do you evaluate an addition expression? Well, you basically evaluate the left-hand side, and then you add it to the evaluation of the right-hand side. And how do you evaluate a multiplication expression? Well, a multiplication expression again has left and right side. And you evaluate in the same way as the addition expression, with the only difference that in this case, you multiply the evaluations. So this is how you get the multiplication expression evaluated. So basically, you have now an expression type with its evaluation function. But let's take a moment to understand what we have done here, and also to see the features of pattern matching in a bit more glory. For example, if I don't have this branch, right? If I don't add this branch, then compiler knows that I'm actually missing something, because this expression can also be multiplication expression, but we're not handling that. So it really points to that location where we are using this expression, and says that, hey, you are missing a branch, and then you can add that branch. So this way, compiler, if you're using sealed interface, compiler really helps you to identify all the places where you are missing a branch. Also, if you add a new branch, so for example, our expression, let's say, supports division, then we can simply add a new branch, division branch, and then compiler will again point at all those places where we are using expression, and then it will also tell you that, hey, you are missing division. So this is very useful, because if you have a sealed hierarchy, and if you do a switch over that, over let's say a variable of the type of this sealed interface, then at all those places where you are using that, compiler will say, hey, here you are missing to handle a particular scenario, you are missing a branch. So that is really useful, because imagine this expression is being used at 10 different places, compiler will point you at all those places and tell you that you are missing this. So it really, compiler really helps you to identify all those places. So in this case, I'm just gonna add that branch to an expression, and now compiler is happy. Also, maybe let's explore a few more things. So these branches are evaluated from top to bottom, and we can also add very specific branches. Like if you want to, for example, handle a scenario where your division expression has a dividend, and the right hand side is, let's say, a constant expression, where you have a value which is a divisor, right? And you want to handle a scenario where the divisor is 0. So you can write actually that whole expression here, and then this branch would be evaluated only when this expression is true. So only in the case where your expression is division expression and it has right hand side as constant expression and the divisor is 0. So this is the power of pattern matching. It really allows you to handle these specific scenarios in a such readable and easy way. So in here, what you want to do is, if the divisor is 0, we want to simply, let's say, throw new arithmetic exception saying that, I don't know, divide by 0 or whatever. I mean, you can basically throw that error here. Another thing, so this kind of pattern matching expressions, so this is basically pattern matching for switch. And when you use when to define some specific cases, those are called guarded patterns. These are also part of pattern matching for switch. And as I mentioned earlier, these branches are evaluated top to bottom. And that's why it is important to have this division expression, which is a more generic case, below this division expression, which is a more specific case. Because if you do like this, well, all the division expressions would be evaluated by this branch, and then this branch would never be evaluated. And that's why compiler knows that, and that's why it gives you this error. So you put your specific cases before more generic case. Okay, so I wanted to show the power of pattern matching. That's why I added these examples. But for our puzzle, we are not really interested in that. We are only interested in this part. And also, let's take a moment to understand what we have done here. So what we have done is we basically took the, let's say, data model part and we implemented it here. And then we took the behavior part and then we implemented it here. So we basically separated the data from behavior, and we use the algebraic data types to implement the data part, and then we use pattern matching to implement the behavior part, right? So that's the division between data and behavior, and use of algebraic data types and pattern matching. Okay, we actually took quite some time to implement expression. Let's move on, because the next thing that we are going to do is add the generator type. Now, generator generates all possible combinations, and generator is actually not the core of this talk. That's why I have it already implemented here. So generator is already implemented for us. What we see is that generator basically generates all possible combination of values by taking in a list of variables and an indication whether you want unique values or not. And then when you call this combinations on it, it gives you this list of maps, basically all the combinations of different values that these variables can have. And generator uses depth first search. It's also pretty interesting implementation. So if you are interested, I will share the link to this Discord at the end, and you can take a look. If you have questions, also reach out to me, or if you have improvements, just send pull requests. It's also fine. So before we move on from generator, so what generator does, it takes a list of variables and an indication whether you want unique values or not, and then it gives you combinations of all the values that these variables can have. That's this generator part. And then moving on, we need to create a couple more constraint types called unique values constraint and equality constraint to represent some specific constraints. And I'm going to do that. I'm going to create these constraint types, and I'm actually going to put them in a sealed hierarchy. So let me quickly do that. Let me create an interface, call it puzzle constraint. And let's make it sealed. And we will see why making it sealed interface is a good idea in a bit. But first, let me implement those. So we had unique values constraint. Unique values constraint, which implements puzzle constraint. And then we have equality constraint, which basically is useful if you want to check the equality. And again, equality constraint has two sides, which are now expressions left and expression right, to check if these two expressions are equal or not. And so in this case, we have created a sealed hierarchy of these two implementations. But even when you have sealed hierarchy, you can add a specific behavior to each type. So for example, for this equality constraint, I want to add some function which basically returns a boolean which indicates if the equality constraint holds true for a set of values or not. For that, I'm going to create a method called holds true for, and this will take values. So basically map of string to integer values, and then how do you implement this? How do you know that an expression holds true for the values or not? So you basically evaluate the left hand side with these values, and let me import this. Oops, let me import this statically, and then compare it with the evaluation of the right hand side with values. So when the evaluation of left and right are same, that means the equality constraint holds true for these values. Okay, so we have our puzzle constraint with these two constraints implemented, and what is left right now to do is to implement the puzzle solver, which will basically use generator and expression evaluator to find the solution. And for that, I'm going to create a new record. Let's call it puzzle and not puzzle solver. So let's call it puzzle, which is a record. And this is basically something that represents our crypt arithmetic puzzle, which is a constraint programming problem. And if you remember from constraint programming problem, it has variables and constraints. So I'm gonna create a record which is of combination of variables. Let's call it variables and list of constraints, which are basically puzzle constraints. Let's call it constraints. And let's import list. Okay, so this represents our puzzle. Then when you have a puzzle, what do? You solve it. So public void solve. And now we will basically implement the solution for it, but in a minute. Now, before we do this, let's imagine that you have the solution with you. You have it completely implemented. How do you know that your solution works for a particular puzzle or not? How do you know that your puzzle that you started with is having a solution and then you find a solution for it? Well, the way to find that out is to write a test for it. So let's write a unit test for this. Generate test. Okay, and let's create a method called as test solve. The name could be better, but let's use this for now. Let's add the test annotation for it. Now we want this test to implement our puzzle send plus more equals money. So we need all these variables, right? Now I have some code, which basically now I'm going to generate, which will quickly get all these variables here. And these are all these variables which have all these constraints. So SENDMORY, and they have these constraints from 0 to 9, except for M, because M has constraint 1 to 9. Okay, then we're going to create a puzzle, and this puzzle will have list of variables and list of constraints. So what is the list of variables? So list of variables is basically SENDMOR and Y. And then we have constraints. So list of constraints, and in the constraints, we know that we want unique values. So we're going to create a new unique values constraint. Let me import it statically. And then we will also have an equality constraint. Also import this constraint and import this statically. And this equality constraint should somehow represent our puzzle, which is send plus more equals money. And we will do that in a bit. But before we do that, let's implement the solve method in puzzle. And I wanted to show this to you because I wanted to show that a puzzle is basically having a list of variables and a list of constraints. And the constraints here could be unique values constraint or equality constraint, right? So once you have this, with that knowledge, let's implement the solve method here. So how do you solve a puzzle? You basically generate all the combinations, you evaluate all these expressions, and when all constraints are satisfied, you have your solution. So let's get the generator in action. So generator is basically new generator, and generator requires variables. So let's pass those variables. And it also requires an indication whether you want unique values or not, right? So let's do that. How do you know you want unique values? Well, you look up in the constraints and you see if there is unique values constraint. So let's do that. Variable unique values needed, and you would look up in the constraints and you see if any of these constraints actually constraint is an instance of unique values constraint, right? Let me make some space. So if you have unique values constraint in the list of constraints, then you know that you need unique values. So you pass that to generator, and now generator is able to generate all possible combinations. And then what do you do? Well, when you do generator.combinations, it will give you all these combinations. Let's go through them one by one. So you could simply use a for loop and go over all these values. And then if any of these values is a solution, so let's just say is solution values, then we'll do something with it. Let's for now implement the is solution method. So how do you know that your set of values is actually a solution? When all the constraints are satisfied. So you basically return constraints dot all match, and all these constraints are matched when you know that if all these constraints are satisfied. So it's satisfied constraint comma values, and when all of them are satisfied, then you know that you have a solution. So how do you implement this is satisfied method? Well, and when a constraint is satisfied? Well, a constraint is satisfied when the constraint is instance of equality constraint, and let's call it equality constraint, and equality constraint holds true for given set of values. So then we know that our constraint is satisfied, and then we basically return true. But there is something interesting, and also this constraint can also not be an instance of equality constraint, right? It could be something else. What do you do then? Then you basically ignore, because the other thing is unique values constraint. So for unique values constraint, we have already taken care of it, so we don't want to worry about it here. So what we do is, it is either an equality values constraint, either it is not an equality value constraint, or if it is equality values constraint, then it holds true for the values. So that's you know that it is satisfied. Now there's something interesting happening here, and that interesting thing is we are using this instance of expression, so pattern matching for instance of, and we create this variable, but we are able to use it on the right hand side of this expression, and that is because we have shorthand or and a negation here. So because of the shorthand or, this right side is evaluated only when the left hand side is false. Otherwise, this is not evaluated. And this is false only when this is true. What that means is constraint is an instance of equal values constraint. So only when this constraint is an equal values constraint, you evaluate the right hand side. And that's why we are able to use this on the right hand side. So if you replace this with shorthand or if you replace this with or if you replace this with a normal or, or if you have shorthand and, or if you don't use this negation. In all these cases, you can't use this on the right hand side, but only when this combination you are able to use it. So compiler is actually doing something smart, and it's really useful for us. Okay, so then we have a solution. What do you do with it? Let's just simply return the solution here. For that, I need to change the return type. This returns now a map of this. And when you don't have a solution, well, let's just throw an expression, throw new legal state exception saying that no solutions found. Okay, now we have solve method implemented. Let's move on and do the rest of the things in the test class. So we somehow want to represent this expression. Well, before we do that, let's quickly go to expression. And here I want to generate a bunch of methods. So I generated these 4 methods. What they do, each of them actually gives me an instance of each of these expressions. So these are static methods which are helpful to create these instances. So const var addition and multiplication expressions by passing in the values and names and left and right expressions. So basically some helper methods to create instances of these records. Okay, now let's come here. So equality constraint has 2 expressions, right? Left and right, which are basically these. So left hand side expression is send plus more, and right hand side is money. And this is nothing but an expression dot add of send and more. So you add send plus more, and then you get money. Then what is this? This is basically a combination of 4 of these variables in such a way that it creates a number, right? A 4-digit number or a 5-digit number. Now, because these are single-digit numbers, what I can do is I can use the fact that I could get the value of this 4-digit number by taking the value of this s, multiplying it by 10, and then adding e to it, then multiplying this whole expression by 10, and then adding n to it, and then keep on repeating that. So it finally gives me a number. So I'm going to create a method called create number, which will basically take these 4 variables. Similarly, this is taking these 4 variables, M, O, R, and E, and this is the same thing but with 5 variables, M, O, N, E, Y. Okay, and how does this create number method look like? Let me create that. So this is basically the same thing as we discussed. Take the value of this, multiply it by 10, add it to the next one, multiply the whole thing by 10, add it to the next one, and then keep on doing that until you have the final expression. Okay, so that's what this does. Then what do? When you do puzzle.solve, we will have our solution, and then I'm gonna do some assertions. Assert equals. So I'm just gonna assert that this, which is the left hand side, it evaluates with the solution to the right hand side. So basically just checking if the equality constraint is okay or not. So evaluate this with solution, and this was a good assertion, right? And then we know that send plus more is equal to money. And then let's pretty print the solution. So I'm gonna print it nicely, this solution, and let me create the pretty print method, which is basically just using string templates and prints it nicely. Okay, so I have everything. Let me run this method and see if it actually works. So I run this, and gives me a solution. So basically we have our puzzle solved. Excellent. Now, what we said was that we will create easy to read, easy to understand code. But actually there is one small thing that is bothering me, which is this. So here there is a lot going on. There's negation, shorthand, or, and all of that. Can we make this easy to read? And can we also use the fact that puzzle constraint is a sealed interface? Well, actually we can. Let me quickly do that. So switch over constraint and let me add these two things. So if it is unique values constraint, we actually don't worry about the variable name, and we simply say it is fine because we have taken care of it here. And if it is equality values constraint, then we do equality constraint holds true for these values. And now it's easy to read, right? So how does it read? It says that a constraint is satisfied when it is an unique values constraint, or if it is an equality constraint and that constraint holds true for the given set of values. So now this is more readable. Let me run the test again to make sure that still get the solution. And we do. So perfect. Okay. Now let's go back to expression, because this is basically the core of our talk. What we did here is that we separated the data from behavior, and we use algebraic data types to implement the data model, and we use powerful pattern matching feature to implement the behavior. Okay, now coming back to the presentation, this is what we did. We kept data and behavior separate. We used algebraic data types, which helped us to model data so that only valid states are allowed to exist. And we use records and seal types to implement product and sum types. And we use pattern matching features that helped us to implement behavior or functions that are operated on the data. Now, this style of programming, where we separate the data and behavior, and we use algebraic data types to implement the data and pattern matching to implement behavior, is called data-oriented programming. So in data-oriented programming, it encourages us to model data as immutable data and keep the code that embodies the business logic separate from the data. It is really explained nicely by Brian Gates, the Java language architect at Oracle, in the article at this link. So if you go to that link, you should be able to read the article. It's pretty extensively explained by Brian there. So he actually talks about 4 principles. First one is that model the data, the whole data, and nothing but the data, because data is at the core of data-oriented programming. Next, data is immutable. So you use immutable data structures like records. Records are shallowly immutable, but you can also use other immutable data structures to model data, because that gets rid of a lot of problems. Validate at the boundary. So you basically, oh, excellent for sharing the link to the article by Brian. So validate at the boundary, because data-oriented programming is really useful for small subsystems. And there, if you validate at the boundary of that subsystem, then you can use that valid data inside that subsystem and transform it in the way that you want. For example, if you have a system which basically takes a amount from another system, and that amount is coming as text or a string, you validate it at the boundary that it's actually a valid amount, then you convert it into a right type. It could be double, or it could be big decimal, or anything, and then you use that within your subsystem the way you want, because now you know that that amount is valid. And then make illegal states unrepresentable. So the way we did with expression type, where we created these different algebraic data types to represent only valid states, and that is actually also an important aspect of data-oriented programming, because by using these features of records and seal types and pattern matching, you make illegal states unrepresentable. So you use arity and pattern matching, in other words, record, seal types, and pattern matching to enable easier data-oriented programming. Also, how does data-oriented programming and object-oriented programming compare? So object-oriented programming is useful when modeling large complex subsystems where modularization is important. And also data-oriented programming is suitable for simpler, smaller subsystems. So this is very briefly about data-oriented programming. But if you read the article, you would get pretty extensive information. And that's about that. And well, yeah, if you want to play around with the source code, you can find the source code here at this link. If you want to reach out to me, that's my Twitter handle, so you can connect with me or ask questions if you have, or any suggestions for improving. They are also welcome. That's all I had to share. So yeah, Danilo, if there are questions or anything.
Oh, that's amazing, Bala. Congrats for your talk. It was
Oh, thanks.
so clear the way that you did that. So smooth that you went through the problem and to the solution. That was awesome, man. And the code was amazing. Being able to read that. Even someone answered here that reminds him the college project. But I remember that at the college we did it in a way that we couldn't even understand the code.
Oh,
I don't know
perfect.
about you, but I remember when I was in the college, people did something like this, but no, we couldn't understand that. And the way that it did, whoa, it was so clear, man. So clean code and elegant code as you proposed it for us, which was all about that.
Oh, thank you. Thanks a lot, Danilo. Yeah, and if there are more questions about why is it done this way, why is it done that way, or why not use this, or why use certain thing, please reach out to me. I can also answer them. Yeah.
This, oh, go ahead, Max.
No, I'm just. I'd like to adding that this is the way I think is more tangible way to show to the audience how important is the type safe of Java or any kind of typed language. And the most of the developers, especially the beginners, starts to say, "Oh, Java is so verbose, and why I need to define the types and so on." That's the reason why it's so important typing. You use the compiler to help you to develop those things. How powerful is it? So why not to pay attention with that? So I think this is the way that we can make this tangible to the people to see how important is a language, a type of the language. That's the reason why we can use that. And we know that, okay, we can do this on Python, we can do this on C++. Why not? We could do this in Java, but right now we can do this one. And that's the reason why I think it's so important. And again, thanks and congratulations, Bala, because this dynamic and way to bring the problem and so how can solve it is very impressive. Thanks so much.
Thank you, Max. Thanks for the kind words. And I do agree with you. Static typing is really important, and it really helps you to not make mistakes. You use compiler as your friend that guides you in the path in the right way. And it is also what Java has done really well. The pattern matching features are so powerful. It's so amazingly done in Java that you can really use them, and you make your code so easy to read. Now, if you just read the code, it really tells you what it is really want to do. It expresses the intention of the programmer really nicely. So that's again another thing that I really like about Java. And to talk about verbosity, right? I think you can write really small and really cryptic code. No, this does not really express the intention. But with Java, I think the balance of verbosity is so great that you can write really concise implementation, and it's really still very expressive. So that's something amazing that the Java architects have done, and that's why I love Java and been using it for years and years. So yeah, definitely all these advantages are there in Java, and that's what makes Java so powerful.
Yeah. Be explicit is very better than be implicit because we know how hard it is to find out bugs, to recognize those things in the production when we are using something like that, like a compilation and hints like that. It's very important, and we know, and probably I hope that the people that watching us right here and we will be watching us to be happy to get this kind of solution, the kind of example. And thanks again, Bala, for bringing this thing. Also, I'd like to thank Gabriel. Gabriel said great content. Thanks again. Thanks, Bala.
Thank you,
Also,
Gabriel.
Hassan say thanks for the great talk, Bala, as
Oh, thanks,
well.
Hassan.
Yeah. And okay, Gabriel said that he is in a Java 80 yet, but you can test it by yourself in your machine. Why not? Am I right? You can download your Java 17, 21, or 22. Pretty soon, 23 coming, but you
Yeah.
can get start to test and so on. Am I right?
Yeah, you can
And
see I'm using Java 23.
2023. Oh yeah,
I'm
great.
using 23 early access, but I mean, this is pretty cutting edge. You can still use 17, 21. I mean, if you want to also use the preview features, just use the latest Java that is there, enable preview, try some things around, hack around, give feedback to the team as well.
Yeah, we
Uh,
didn't say anything about Project Amber, but it's coming from Project Amber. Am I right?
so all these features, records, seal types, they are all part of Project Amber
Oh,
and pattern matching, of course.
I mean, I don't want to spend more time. I know that Bala has some needs to right away, but Bala, feel free to say your questions. I will. Can I hide your window right now and bring us
Yes.
in a
Yeah.
big screen? And
Okay.
also, I'd like to thank you, and I give you opportunity to say something. So feel free to give some tips or something to our community. You are always be welcome to be again to share knowledge and so on. Okay.
Hey, thanks, Max and Danilo, for the opportunity. I remember we spoke at EclipseCon, and we said that we will definitely do this thing. So finally, the time has come, and we could do it. So that was really great. Thanks for the opportunity, and well, thanks everyone for joining in and all the nice discussion and nice feedback. Again, my contact points are there in the presentation. So reach out to me if you have anything. And I really have to go. I'm actually already a bit late, but thanks, Max and Danilo, for the opportunity. And let's
Yeah.
see you. See you next time. So thanks a lot, everyone. Thanks. Bye
Cool.
bye.
Thanks,
Bye
Bala.
bye. See ya.
Yeah.
Okay, I think Bala free. Okay, Bala is free. So thanks again, everyone, for watching us. Danilo, do you want to share something, something to the audience, and also if you before at the end we can switch to Portuguese as well if you want, of course.
Oh, I guess we can keep going with English.
Sure.
This was an amazing talk, and Bala did an awesome example. That is an example that we can see it in some interviews and at the college. That it can show that we can do a good code even being a small challenge. So we can always do that. So I like to think about that when we craft the code we can put something that will make sense and we can read it in a way that in the same way that we think about it. So that was the main example that Bala could do it in the best way possible. So I'm really glad to be here to help our community to see this kind of example.
Yeah, amazing, amazing. And also, I'd like to thank you, Danilo, because Danilo was the main
Oh,
contributor to make those things happen. Because Danilo have been talking a little bit more with Bala and bring this one to us, and it was amazing. I think that this kind of talk we used to do more time, so maybe bring another content. Let's talk to the people that we meet on international conference and so on. We got Ruslan, we got Adam B, and maybe we can bring them together to share more knowledge and make our community stronger as we are now right here. Am I
yeah.
right?
And not
So
and also if you are watching us, send us a message if you have any content that you can share with your community, with your Java community. It will be amazing to have you here on the stage and sharing it with us. So send us a message. It will be a pleasure to have you here with us sharing it.
look, Dorival is here. So
Oh, hey
Dorival,
Dorival, how are you
we're
doing?
missing you, man. Dorival is a speaker that we meet on so in Java Day, if I'm not wrong. Am I right? In
Yeah,
the you know, what is the city that we go?
Oh, I don't remember the name, but
Okay,
it
but
was in Rio Preto,
Rio
right?
Preto, I think
Yeah.
so. Yeah, yeah, Java Day
Also,
on there.
also
Yeah,
he joined our meetup in Campinas last Tuesday, so he was there sharing, helping us with our community here. That I'm one of the coordinators. So Dorval, also, if you have a talk, send us a message. You will be here in the stage with us. I know that you have a
yeah.
lot of content to share.
Yeah, that's it. That's it. And amazing. And also, I'd like to thank you, everyone, to be here. Thank you again, Danilo, for helping me, for support us. Thank you for everyone that watching us to be here because we are doing everything right like that for you guys, for you on the chat, you on watching us. If you are interested in some topic related to Java, related to how to work with, for example, Danilo got a special talk talking about vector database. So maybe
Oh,
we can do this again. Why not? All right, we can bring it, but let us know. You guys can reach out to us on our Twitter. So we in the X Twitter. Oh, I need to change it to X. Okay, Max de Arruda at Max de Arruda. Danilo also at Danilo PDL, so we'll be able to reach out to us. Send us if you wanted to watch some content right here. It will be a pleasure. So that's it.
yeah.
Let's go. Hey, let's continue our day.
Yeah, for sure, Max. Thank you for this space. It was amazing to be here also.
Okay, guys. So see you soon. See you
Yeah.
next time. Bye bye.
Thank you. Bye bye.